So this is one of my favorite things that I want to go over just to nail it in and make sure everybody is following this good practice rather than creating 10 different files called version 1, 2, 3, version 3 edits, version 2 old, version 2 latest. I don't want to see any of that, and that's what this lesson is all about, because I want to go through using version control systems. So before I get into exactly what that means, I just want to kind of frame the problem, right? Because most likely you found yourself working on a big project where you have a bunch of different files and you keep making copies of the same one, different versions, make sure you backed it up. Don't lose any information in case the new version doesn't work out, or in case this new feature doesn't pan out the way you want it to. And so you end up with all those different files with the crazy repeated names, like I mentioned. And at the end of the day, despite your best efforts to name them, it's really hard to keep track of which ones are going on and of which ones are which. And of course, this just gets way worse when you start working on projects with multiple people involved. So nobody else knows your naming convention, nobody else knows which order they were edited in, which ones were made first, which ones are the finals, which ones are tests, and that kind of thing. So to solve this, we're going to use what I said, version control systems. So a version control system is a system that records changes to a file or a set of files, so you can recall specific versions later and track the lineage of your code over time. So imagine your team is working on your code and you're adding features, and at some point you realize that not all the features you added are working, and you want to revert to a previous version of the code where there's no bugs. Potentially, maybe you can give that to people for the meantime rather than releasing something that you know has things in it that don't work. So these version control systems would allow you to revert to the selected files at a particular place. You wouldn't have to, make sure you can control Z to undo it, or make sure you've got backup stored somewhere. Instead, version control will just be tracking these changes over time, and you will just be making checkpoints along that history, which you can move to at any given point. So that's just one of the things that these systems can do, really. I want to go through a little demo of showing some of the key points, but another one to really highlight would be they're great for collaboration, right? They're used for not only tracking changes, but being able to share different versions and merge different changes into one final master thread of code. So you can find mainly 3 different types of version control systems: local version control systems, centralized version control systems, and distributed version control systems. So those local version control systems keep track of a file or set of files in your local machine, just the one you've got here, not remotely, not on the cloud, not on the internet or anything. So not very useful if you're collaborating with a team, but very useful if you want to track your own progress. Centralized version control systems keep track of files in a central system where many computers might have access. The problem with this is that all computers rely on a single machine, so that's kind of a point of failure. And if the hard disk of a central database becomes corrupted, you're going to lose absolutely everything. And finally, you've got distributed version control systems, where the files are mirrored from a central system. So if any one particular computer dies, all of the different client computers, the ones connected to it, maybe you and the rest of your teammates, can copy the file to restore it if you need to. So you can copy your files up to that server, so it'll be restored. So kind of distributed means that you've got different versions saved everywhere, and there's no single point of failure in that case. So Git is what I want to talk about, and Git is the name of a distributed version control system. It's the most common tool for code collaboration right now, and it really is, it's probably the most important thing which you should learn. So Git keeps track of changes that the user makes to the directory, and it's a distributed version control system. So as you're going along, you'll be making changes to your code, and pretty frequently you should make checkpoints, basically. We call these checkpoints commits. You're committing to those changes at that particular point. So when the file or files are committed, the information goes into the Git repository. So the Git repository is really just kind of the file or set of files which contain everything to do with your version history, and commits are basically you adding data to that place. So you're tracking these changes. You can think of your commits as like a snapshot of your files at a certain point in time. So if you accidentally make a mistake on one of your commits, you can always revert back to a previous one. And again, that's just because Git is storing the entire history of all of these checkpoints in your code. So it's important to know that Git compares the previous commit with the current state and adds the changes, keeping the commits as lightweight as possible. So it doesn't add, everything, it just adds the changes. And those changes don't necessarily correspond to new information. It could also be you're deleting things. So if you were deleting information from a version, Git will add that deletion as new information. So you never actually lose the information. Instead, it's just all kind of added on, even if that change which you're adding is actually removing files or removing data. So each commit has an identifier in the form of a 40-character string. And this is going to help us when we want to go back to one of the specific commits we have in the repository. This hash is always going to be unique, and it represents a unique ID for each version of your code. But how does Git know when our files are ready to be committed? So Git has 3 states for the files in a repo. I just mentioned now, repo is short for repository. So the 3 different stages for files are modified, staged, or committed. So let's assume you start here from a committed file, and this can also be a set of files. And when you modify this file, Git notices that this file has changed from the state that it had in the repo. When we're happy with those changes, we can stage those changes, and the file is marked as ready to be committed. And finally, we'll move those staged files to the repo by committing them. So staging is basically everything that you will be adding to your commit when you make it. One of the most powerful tools in Git are branches. So branches allow us to work on different versions of the code in parallel. And a branch is nothing more than a pointer to a previous commit that you've made. And from that pointer, we'll create new parallel commits. So to explain branches, take a look at the pointer named main, which is the name of the branch you have by default. And on top of main, we can see a tag saying head. Head represents the current branch which we're working on. So for simplicity, we're going to give a single number to each commit, but in reality, as mentioned, that each of them has a 40-character identifier, which is a unique ID. You can add more branches to this commit. So let's say, for example, that we create a new branch called features, and we want to move to that branch. So head is now tracking the features branch. And here on this features branch, we could be working on a feature which it doesn't matter if it's kind of halfway working. We can develop it and test it until we merge it with the main thread of the code. And this is the way you should be working on every new feature. Every single new feature that you want to add in, make sure that you branch off from your original code so that the main thread of the code is always just everything that you like and is working. Everything experimental or kind of in progress should be broken off in a branch. So if we start adding commits to this branch, it's going to contain new commits, while main still points to the same commit where we branched off from. Main hasn't changed, only this branch has changed. So you can add as many commits as you want to this branch, and the main branch will stay the same unless we move to that branch and make commits from there. So now if we move to main and start adding commits, you can see that kind of we're working in parallel now. Both branches are different, and somebody's working on main. They probably shouldn't be, they're probably working in a different branch, but again, that could be happening in parallel. So when we're ready to apply the changes in one branch to another, we're going to merge them. And that's the key terminology there, merging of branches. So in this case, you want to merge in from the experimental features branch into the main branch. And at that point, the features branch can be deleted. So any change that you make to a branch will be then reflected in the main branch. So all those commits which you made kind of become part of the main branch of the code. All right, so now we know the theory. How do we apply it? Let's take a look. So we use Git from the terminal. So let's open that up, and you can see that we've got a folder here, which is the one I'm going to work from. I'm going to make this into my Git repo. So in the terminal, I'm going to change directory to that folder, cd inside, and use tab completion. And we can see there's nothing inside it. So here I'm going to create a Git repo in this working directory by running git init. And you can see that you still have nothing in here. But if we list all the files, including the hidden ones with the A flag on ls, we can see that there's a hidden directory named .git. This is a repository storing all of the information about the entire history of changes to your code. It also stores the current state of your code and the branch that you're on. So we've got a couple of modified files now, and Git knows this because it's comparing the last commit with the current state of the directory and everything inside it recursively. So how do we check the state of our files? Pretty simple, we just run git status, and you can see here that 2 files are modified, the ones that we've just created. The files are in a modified state as we discussed earlier. So if we're happy with them, we can stage them, which means we're preparing them to be included in the next commit. You can stage a whole directory by doing git add dot, so dot represents the current directory as usual, or you can stage a single file by typing git add and then the name of the file. So let's just stage everything for now, but notice that you can just stage a particular file if you want to. And if we look at the git status again, you can see the message has changed. Now our 2 files have been moved to the staged state. So the last step is to commit the staged files. And when you make a commit, you need to provide information about the changes you've made from the previous commit. And this information comes in the form of a message that is part of that commit. So it's the commit message. So always, always, always give a descriptive commit message. Don't give some random message or, you should commit very frequently every time you make a very small atomic positive change. Anything that you're happy with and you want to keep in your code, you should be committing that. Don't let me see you making huge commits where you complete the whole project and then leave a commit message like project complete. Be consistent with the tense and the grammar in your commits. You should always use proper English grammar with capital letters and full stops. There's no reason not to, just because it's a commit message. And your commit messages should always be present tense. So I like to go with, fixes issue rather than fixed issue. That way the commit describes exactly what this commit adds to the code. This one, it fixes the issue. And moreover, more importantly than just the grammar or the tense is just consistency. You should go with those conventions, but always be consistent. I don't want to see commits, some in past tense, some in present tense, some with grammar, some without. Just be consistent and then make sure they're really high quality. So when you make a commit, you'll commit all the files that are in the stage state. And to do so, you just run git commit followed by the -m flag that stands for message. And then you write the message. If you want to include spaces in that message, which you probably do, then you should put them in quotes. And it will look something like this. So a message confirms the commit appears, and now git status says that we're up to date. Awesome. So now you know the basic use of Git, we should look at branches. You can create a new branch from the last commit by running git checkout followed by the -b flag, which stands for branch, and the name of the branch. So what we're saying is we want to check out to a different branch. We want to switch branch essentially. So following the previous example, let's create a new branch experimental features, and you can do that by typing this, and now you've created and switched to a new branch. To check the active branches in your repo, you can type git branch and it will return a list of branches, and the asterisk represents the head, the one that you're currently looking at. So in this case, you can see the asterisk next to our branch, indicating that we're working on that branch right now. So let's add a new file to our branch, stage it, and commit it, and don't forget about the message. Notice my grammar and tense. So good, everything seems to be working fine. We've got 3 files in the directory, but if you remember from the slides, main shouldn't have any of the new changes reflected. So let's check that out by switching to that branch, and now we can see the files that we've got in our main branch. You only need the -b flag if the branch doesn't already exist. And we're back to only having those 2 files. So like I mentioned, the changes are only reflected in the branch that we were working in. So you can work in totally different, experimental, halfway coded versions of the code at the same time, just switch branch. And you should be working in different branches for every different feature that you're working in. Keep only the code which you know is working and you know you're happy with in the main branch, and just merge everything else from other branches in once you're happy with it. So if you want to add your changes into the main branch, you have to merge those features into the main. And we can do that by saying git merge followed by the name of the branch which you want to merge into our current branch. Notice that we're always merging into our current branch. So you can't merge your current branch into some other branch. You need to actually check out the branch you want to merge something into, and then do git merge the branch which you want to merge into your current branch. So now notice that the files have appeared in this branch. Nice. So one of the first things that we mentioned about Git is that it's distributed. And that means that the repository and all the changes are backed up by many computers and a central system. But how do we set that up? We obviously haven't done that yet. So let's look at how we communicate with each other to share these files. One of the most popular solutions is GitHub. Actually, by far the world's most popular solution for doing distributed version control. And this is just absolutely vital. What I want to point out here, just to really highlight, is GitHub is different to Git. So Git is a local version control system, and GitHub is a way that you can use Git to communicate in a distributed way and store versions of your code online and share them easily with others, as well as locally. So GitHub allows us to host and manage our repos online, and that way any member of our team can access the files in the repo, and you can even open source code and have other people contribute to it by accessing it through GitHub. So if you haven't already, you can create an account by clicking sign up on the top right, and otherwise just log in. And I want to show you how to create a repo and connect it with our local machine here. So on this page, simply click new, and then let's create a test repo. And good practice to include a README file. This is a file which is a markdown file which will be displayed on the homepage of the repo. So you can include documentation, how to use it, how to contribute, or anything else that you want. Let's tick that box and click create, and that's it. Now the repo's been created. So now we've got this on GitHub, we need to, get it on our local machine. So you can take a look at this green button that says code and click that and copy the URL of the repo. And now you can clone this repo into your local machine. So in the terminal, you want to go to the directory wherever you want this repo to appear. And now we can just clone our repo by running git clone followed by the URL. By default, it's going to create a directory with the same name as the repo we created. Now it's been cloned, you can see inside, and you can see there's a README file, and that's the same as we had on GitHub. So now we've got that remote repo locally. And now we've cloned it, everything is already set up to communicate with GitHub. So committing files to this repo works in exactly the same way. I create a new file, stage file, commit the state changes. But now the new commits are only local. So it isn't communicating to the remote repo by default. To show this on GitHub, we need to do a git push. We need to push those changes. So that git push is a command that's going to upload those changes to the remote repository. Let's go back to GitHub and check if those files are correctly pushed. Yep, we can see that our file is now there. So what about the other way? What if instead of creating a repo on GitHub, I created it locally and now I want to push that to GitHub rather than clone it? In this case, you could do something different. So in this case, we need to basically add a remote origin. So origin is the name of, the typical conventional name of the remote repo, of the kind of, this is the origin, this is the ground truth, this is the key source of all of our information. And that's really what the remote repo should be. So right here, I'm gonna connect my local GitHub repo to the remote origin by using the git remote command, the add command within that, and then I'm gonna give it a parameter called origin, which is the name I want to set this, I want to set my remote repo to. And then I just paste the URL of the repo. And what that means is that you're going to add a new remote connection to this local repo. So in this case, we're adding a connection that's going to be called origin. That's the conventional name for the remote repo. And the value, which is the URL it's going to point to, is that remote repo on GitHub. So at this point, no branches actually exist. To create one, I've got to make at least one commit. So I'll add some files and then commit to those changes. And the other thing that I want to do here is just rename the main branch. Because I created this with Git, not GitHub, the default branch is named master, not main. Now, if I do git push, I'll get this message and it will tell me that I need to basically specify which one I want to push information to. So if I just copy this command, this is exactly what I need to do actually. This is saying push the upstream branch called main on the remote repo called origin. So our terminal should say a message saying the upload was successful, and let's check that out on GitHub. Let's take a look at our GitHub repo. And as you can see, files that were created locally are now in our GitHub repo. And really, that's it. That's like a good round tour of the key features which you need to be aware of to start using GitHub. And really, you should be using GitHub all the time, Git and GitHub. You should be tracking all of your code. You should be making consistent commits. You should be working on independent branches for features which are in development, and then you should be merging them in. And you can even start using this to collaborate on code with people. So as you can see, Git is a powerful version control tool which helps us to keep track of all of the changes to our code over time by making these checkpoints, these commits in our working directory. And you can use this to go back in time to previous version or to switch between different branches where you're working on different things. And that makes it really easy to collaborate with other teammates as well. There's even more features I'm just not going to go into any now because it's so huge, but you should be using this, get familiar with it from day one. It can cause a lot of issues as well, but really what you need to do is not know everything, just look it up. There's plenty of documentation, really good documentation explaining how GitHub works. There's people around to help, and there is a lot of support online for finding out how to solve any of these issues that you're struggling with. So you and your team can kind of use that to collaborate between Git and GitHub. And with that in mind, you should be able to get going using this industry standard tool to work on software development.